Often, when factoring polynomials, you'll come across this expression that is called a difference of two squares. A difference of two squares is one perfect square that is subtracted from another perfect square. This difference can be factored into two binomials using the following identity. A squared minus b squared equals the factor a plus b times the factor a minus b. That is, a term squared minus another term squared is equal to the sum of those terms times the difference of those terms. Let's look at an example. Here we have 4h squared minus 25k squared. First, we'll rewrite each term as the quantity squared. 4h squared can be written as the quantity 2h squared. 25k squared can be written as the quantity 5k squared. Now we can factor this expression as the quantity 2h plus 5k times the quantity 2h minus 5k. Both terms in the difference don't have to have exponents of 2. If the terms have an even exponent, we can rewrite them easily as squares. Let's look at 9x to the 4th minus y to the 10th. The first term can be written as 3x squared squared. The second term can be written as y to the 5th squared. Now we can factor this expression as 3x squared plus y to the 5th times 3x squared minus y to the 5th. One note of caution. Be aware that this factoring method only works with a difference of two squares. However, the sum of two squares is not factorable.